Welcome to the Profile Corner. Today's video is part 2 of creating mortise and tenon joints using various different methods. In the previous video, we created a mortise and tenon joint using a doweling jig, and then also a combination blade on a table saw. This is the joint that we created, and then once we created this joint, I created an identical joint using the PantoRouter, and the joint is here and it's still together, and I'll have to probably knock this apart. We're going to be creating another joint similar to this today. However, it will not be centered in the board. Instead, it'll be offset to one side slightly. A doweling jig is quite nice in that a good one will always center the holes in whatever board this is gripped onto. In some cases, you're able to add in a shim here when you're mounting it onto the board to offset the jig one way or the other. However, with these wide boards, you're not really able to do that. And so we'll need to adopt a couple of additional tools over what we used in the previous video. In the previous video, we used budget tools that you could pick up secondhand or at low cost. We need to add a couple additional tools into those tools that we're permitted to use. One of those tools that we'll be adding in is a dado stack. This is a dado stack that I bought recently. It's the least expensive dado stack of those that I bought, and I thought that we'd be able to use this on the table saw to make the tenons so that we don't end up with quite such a rough surface as we received when we were using the crosscut blade, so that we'll have less cleanup to do. And instead of using a dovetail jig, we'll be using a drill press that's set up with a fence on the table. There's various different guidelines in terms of the size of a mortise that you would want to use. In many cases, the size of a tenon will be roughly 1/3 to 1/2 of the width of your stock. In this case, I made the tenon a 1/2 inch wide, and part of the reason for that is because the cheap chisel set that I was using from Dewalt has 3 chisels in it, with the smallest of those chisels being a 1/2 inch. And so I was limited to using a tenon that was a 1/2 inch wide. And of course, that's good from a strength perspective, but you may be limited in terms of where you can use this on mating boards, because if the mating board is only 3/4 of an inch wide, then you're only leaving 1/8 of an inch out here on each side, and that would be bad for stability and also strength. And you'll notice here that I dropped down the tenon a 1/2 inch from this top surface, and that's because the top of the board is supposed to mate up flush with the top of this other board, and if I had decreased this distance any, then that would cause a reduction in the strength of the wood that remains in this board, and I didn't want to do that. And so by stepping it down a 1/2 inch, I was able to add a little more strength. So I could have also extended this tenon down, possibly leaving only 1/8 inch or 1/4 inch down here at the bottom of the tenon until it hits the bottom of this board, but I didn't do that. If I needed additional strength, I could have done that. And you'll see all kinds of guidelines on the internet and on YouTube in terms of how to size your tenons. You may want to review those videos and look for those videos that are put out by professional craftsmen or professional woodworkers. Okay, so let's head over to the drill press now, and we'll start working on the next mortise that's going to go into this board. I've drawn the location of the mortise here. I want it so that the board that mates up with this board will have a 1/4 inch reveal here on the outside. And so what I've done is I've brought that in 1/8 inch plus 1/4 inch. 1/8 inch is what the shoulder is going to be on the tenon for that 1/2 inch wide tenon. So that gives us 3/8 of an inch. And then 1/4 inch over from that is the center line of the mortise. And then another 1/4 inch over from that is the other edge of where that tenon is going to be. I've set up a temporary fence on the drill press so that I can just butt this board up, and then the drill bit should come down right onto the center line. I'm just using a standard twist drill bit like I used in the last video, and so I should be able to see when to stop the mortise, unlike the last time where I ended up overshooting the end of the mortise and then I had to plug that hole. Now what I've done here is I've planned to have the tenon this time be 1 inch long, and of course this board is more than 1 inch thick. It's 1 7/8 of an inch thick, and so that should still give us plenty of meat on the bottom here. So the drill press is set up to go down a total of 1 1/4 inches, which takes into account the small roundover that's on the bottom of this twist drill bit. And I think that that'll be okay. So we're now ready to get started. I have the drill press speed set to just over 1,000 RPM. So I think we're ready to go now. And I did switch over to a better quality ruler that I have an easier time reading than the inexpensive ruler that I used the last time. That was the second-hand ruler. So there's our first hole, as you can see right there. I may have it off ever so slightly in terms of the location, but I think that that'll work out for us anyway, as long as they're all done identically to that. And I'm doing about a 3/4 step over, hoping that that'll work for us, so that we don't have quite as much cleanup to do with the chisel afterwards. Okay, so the first 2 holes are now drilled. So I'm establishing the other end of the mortise so I don't overshoot it later on. Okay, so now all the holes are drilled. So we'll take this back over to the bench and then clean that up using the chisels. And by the way, once we do this joint using these methods, I'll be creating a mortise and tenon joint at the PantoRouter again. Just like last time, I'll square up the end of the mortise, and then I'll come back with a wider chisel and I'll straighten the edges of the mortise. And I should mention that there's ways that you can drill square holes using a drill press. There's an adapter that Delta used to sell. It's called a mortising chisel attachment. And you would have to take the chuck off the drill press, put this attachment onto the drill press, and then put the chuck back onto the drill press. And you could then use that to cut square holes for a mortise. The unfortunate thing is that you need a lot of downward pressure when you're cutting that mortise, and that could be problematic for you if you're trying to get that much pressure out of a drill press. The drill press may not be able to deliver. Of course, Delta is currently not making that particular model for the drill presses any longer. There are models being made by Grizzly, Woodstock, Rikon, and a few other companies, but I would not recommend getting one of those. There's better ways to create square joints. Now, unfortunately, the camera keeps tilting up away from this mortise, but I've got the mortise roughed out. I should probably tip it over to get the chips out of there and double check to make sure that it's completely cleaned out. And then if it is, we can head over to the table saw. Okay, so here's the mortise. We've got just a little bit more to clean up in there. I'm going to take care of that off camera, and then we'll step over to the table saw. I have a 3/4 inch wide dado stack mounted into the table saw, and what I've done is I've created a zero clearance fence for the miter gauge, and I just made a single pass. I hope that I have this blade set at 1/8 of an inch above the surface of the table. It appears that we're pretty close, and what I've done with that pass is I've used that to set the rip fence so that I can use it as a stop block to determine how far this board needs to go across. And the way I did that was just by using a ruler, lining the ruler up with a 1-inch mark right where that notch is at, and then I use that to set the location of the fence. Now this has got a Delta Unifence on it. I replaced the fence arm with a different model, but I'm able to back this fence up so that the fence ends with the board in contact with the miter gauge just before the blade makes contact with the board. It's typically not a good idea to use the rip fence and the miter gauge together at the same time. I know that some people will say that if you're not making a through cut in the board, you're able to use both at the same time. In other words, with this rip fence not pushed back. But I don't like doing that, just in case the end of this board gets hung up on the rip fence and that causes the board to tilt ever so slightly. If your rip fence does not slide back, then what you can do is you can just mount a stop block onto your rip fence using a piece of wood and then a clamp to hold that board in place. So what I want to do first here is just nibble a little bit off the end on both sides just to verify that the tenon is going to end up being a 1/2 inch thick. about a 32nd of an inch over a half inch. So when you press raise it ever so slightly. Exactly a half inch. As long as this table saw blade does not, as long as this table saw's height adjustment doesn't fail, causing this handle stack to come up, it should be in good shape. I want to make a pass right at that, just to make sure that I've got that good shape. Verify that it's an inch long. Long here for some reason. We cut that. It's still not an inch long. So you move the rip nuts over ever so slightly. Exactly an inch long there, also on this side. And just verify that it's a half inch. That's a heavy half inch. Take that down with the chisel, that's not a problem. There's a half inch on that side. Okay. Now what we need to do is raise the blade up a half inch so that we can take this shoulder down and also this shoulder down. And that should be good. Now we'll take a test pass on the end just to verify. test fit up and see if the tenon goes into the mortise. And it's ever so slightly tight back here, and I don't think that that's going to be too much of a problem for us. Okay, so what I'll do is I'll take that over to the workbench and just take a chisel and lightly skim off a little bit of material right here, and then also on the reverse side, and then we'll put this together. Okay, that went together. Had a little bit of difficulty here with getting in the alignment perfect for some reason. And it could be that the board that was on the miter gauge was ever so slightly too long, and that was interfering with the stop that we used on the rip fence. So we've got a little bit of a gap down here at the bottom and also up here at the top. It is flush at the top, which is what we want to see. And then we have our 1/4 inch reveal here, which is what we were looking for. Okay, so let's head over to the PantoRouter and we'll cut a mortise and tenon joint on that tool. The mortise and tenon will probably look a little bit different than what you're commonly expecting to see. Now, I have 3 dowel templates mounted up on the template holder. I know the location of this template, but I'm not certain yet on the other 2. I've set this one so that when I bring the board up, the center point finder will be roughly 3/4 of an inch from the end, which is roughly where I want it to be. The one here in the middle, I want that one to be lined up with the center line of the table when this pointer bit is positioned up next to the table. And I think I've got that one set now, and I have locked that down. I have not set the position of this template. And so what I'll do is make a cut, and then I'll try to get this one set into position by using the spacing established by these 2. Okay, so I'm going to swap over to the 1/2 inch router bit that we'll be using, and then we'll get started. I'll be targeting the same 1/4 inch reveal as we did with the other mortise and tenon joint that we created. So I used the 3/4 inch setup block here, and on top of that a 1/2 inch setup block. And so what that should do is center this bit so that it's set up for a board that is 1.25 inches in thickness. And so that should give us the correct offset, or the correct reveal. Okay, so we'll move over to the first hole that we're going to drill, and I need to set the depth of cut. I want the depth of cut to be 1 inch, so I'm going to get out a 1-2-3 block, and I'll be using that to set the depth of cut. Okay, so we're ready to drill the first hole. After we drill the first hole, we'll go on to drill the second one, and then what I'll do is I'll try to use those 2 holes to locate this 3rd dowel template in the correct position. I think I've got it roughly in the right position, but we may need to move it a 32nd of an inch or so. so now we can use this hole and this hole just by sliding that over, and we'll put the bit into the one hole here. Lock it down into position. And now if we put the bit into the second hole that we've got over here, okay, and I can see that we're off by at least a 32nd of an inch. So I need to move this template over toward the camera a little bit. Okay, we're still off ever so slightly. So what I'll do then is to loosen up the location of this template. Put the bearing into the middle of it. And now I can just put the router bit right into the center. And then if I just take out the bearing out of the center here, now I should be able to lock it down into the right position. Okay, we'll come up and we'll test. Okay, so that one is in the correct position. This one's in the correct position. Okay, so now we're ready to move this back into the original location. And then create our third hole. Okay, now we've got the 3 holes cut at the expected locations. So now what we'll have to do is create what looks like dowels on the end of the mating board. Okay, so I need to set the depth of cut to 1 inch. And I'll use the 1, 2, 3 block again to set that up. Okay, so now we need to go for a 1/2 inch diameter dowel. And so I believe that I need to go to a 22 millimeter fowler in the PantoRouter to do that. And I don't recall exactly where I have to have that 22 millimeter fowler to produce 1/2 inch diameter dowels. So we'll set the height to 3/4 of an inch so that it'll be centered on a 3/4 inch thick board. Okay. So now we can go back and we can verify again. Okay, that is probably going to create a dowel that's a little bit over a 1/2 inch. But we can start there and work our way toward the end goal. Okay, so we're ready to cut. See if we can get a measurement on that using my calipers. Okay, that is 0.530. So we're about 3/100ths oversize of a 1/2 inch. So that means I've got to move this bearing a little bit further away from the template holder. And then we can try it again. Okay, that is 0.5215. So now we're still a little bit oversized. So we'll bring it out a little bit further here again. Zero 0.5085. So now we're about 9/1000ths oversize. Zero 0.5065. So we're about 7/1000ths oversized. We're getting closer. Zero 0.503, so we're 3/1000ths oversized. A little closer. Okay, we've got 0.498. So we're 2/1000ths under a 1/2 inch. So that should be perfect to allow us to put that joint together. Okay, so we'll cut the other two. Okay, so if we did this right, this should just fit together with very tight tolerances. And that's going to go together. I'll hammer that together and then bring it back so that you can see up close. As you can see here, it's already starting to go together. So this is a Mortise and Tenon joint created to look like a dowel joint. Okay, so there's the joint put together. I'm going to back it out a little bit, just so that we can see that it's going to go together. Okay, so here's the joint. I've partially taken it apart. And as you can see, it goes together nicely. It's rather tight. So I could have taken the little tenons down, possibly another thousandths or two, to allow for room for glue. But this joint fit together rather nicely. Now the other mortise and tenon joint that we created, we've got a little problem with the shoulder. I'll have to clean that up on the table saw. I have determined why we had a problem with the shoulder in the tenon. As you can see here, if I line up the square with the bottom and the top, you can see here that it's gradually drifting away from the square. And so that's where the source of the problem is at. And looking closer at this miter gauge, I found that the pointer here is pointing at roughly 89 degrees, and it's not up against the stop. It was in the correct position during a previous video because this was cutting square. So I think if I reset this back to 90 degrees, I should be able to straighten out the tenon that was cut so that it goes together as it should. Okay, so straightening out the miter gauge so that it's at 90 degrees again fixed the problem. I do have a little bit that I need to clean up using a chisel because I didn't spend a lot of time setting the height. I just tried to reference it off the already cut surface here. So I'll just clean that up quickly with a chisel right back in here and also back in here. And then I should be able to assemble the joint. Here is the assembled joint after fixing the miter gauge and then recutting the shoulder on both sides. So now it fits together properly and it's flush at the top. And there's no gaps down through here or on the back side. Okay, that's all for today. Thanks for watching. Bye.